Good morning to everyone. And what we tried to do this morning is repeat yesterday's music, just from the standpoint in the early going. We had misidentified a song. That was Let It Be with the Beatles. And before we get very far here, a reminder, tomorrow is the midterm. So we will come in we'll try to give you as close as I can to an hour. I'll be about 55 minutes is hopefully what we have. It'll be 30 questions, and it'll be no calculator, no notes, just the paper for the midterm and some scratch paper. But you'll have about an hour for 30 problems. And so what we're going to do today is do some more review. We did that yesterday, and there's some problems I wanted to look at. But there is a phrase, and Ben, what I'm going to have you do with camera 2 is take up in the upper right-hand corner to your right, where I have something written there. We're going to look at that in a moment. And the idea is when you prepare for a test, there's certain things you have to be careful to do. Now, one, you need to do problems. I mean physically do them, much as we're going to do in here today. Not just look at what you've done, but do things. Practice by doing. But Ben, I want you to go to that statement up in the upper right-hand corner of the screen. And it says, make sure you can do what you think you can do. Okay, so I'm not worried about this part, just this part. So just bring that in tighter, and I'm going to walk off camera. Just bring that in tight. You can come back to me for a moment if you want while you're doing that. But the idea is that if we have problems we're confident in doing, we tend not to practice them, and what do we do instead? Spend our time on things that are giving us trouble. And the key is practice the little things that you feel good about. If you can do those well, you'll do well on the test. So don't just start at the beginning and then every problem in row. Look for the things that you, okay, I can do this, do it quickly. You're trying to build up your confidence, but make sure you can do what you think you can do. I didn't hear that statement until I had had 3 years and what would be considered a baccalaureate program. That means I was taking about 18 units a semester. 3 years I was in my upper division work, and somebody said that to me, and it was like, duh, that makes sense, but I never had thought about it. Because usually we really spend so much time looking at the tough stuff. Now, another thing, don't just look at your review test and say, okay, I can do that, I can do that. Redo it. Practice it. Because if you look at it and then you say, I can do that, and you don't redo it, on the test, you'll say, I remember I could do that, but I didn't practice it, and then I forget. So there is a problem that I'd like to start. It was one that was just asked me just at the end of the hour. We didn't actually present it this morning in the early hour as one of the review problems, but I liked it. I'm going to write it up here. 5 over 24. Let's see, yeah, it's 5/24. And I want to add to that the following, and it's 7 over 50. And when I wrote the problem, I was just trying to think of some denominators that were so-so. Nicely done, Ben. I was looking at some problems trying to get something that would be nice because we need an LCD. Now, without making this too much of a hassle, let's think of just what we can do here to write these as a product of primes. When you see 50, I hope you see 2 quarters. So the 50 is 2 times 25, and 25 is 5 squared, right? So the idea is you do not have to do the division process if you can see that this is 2 to the first, 5 to the second. I hope you can see that just by looking at it. Now, what about 24? What do I multiply together to get 24? 8 and a 3, 2 and 12, right? But if I take 8 and 3, 3 is 3 to the first. Now, how can I write 8 in primes? 2 to the third power, 2 cubed. Remember, 8 is 2 times 2 times 2. Now, how do I get my LCD? And that was the question that was being asked.
You take the third times 5 to the second times 3 to the third.
Okay, you jumped right to the solution without going an intermediate step. You were correct. What was stated was valid. But as an intermediate step, and what Travis said was you had 2 to the third, 5 to the second, 2 to the third, 5 to the second, and a 2 times a 3. You have the 2 to the third. I don't need the 2. Here's what was said. I didn't articulate that very well. It was stated correctly, and I'm just doing an injustice to it. That is your LCD. But the question, if I look at this, how did I get the 2, 3, and 5? Well, because those were what? The primes I had here. I don't repeat anything, but I list as a multiplication, a product, all the primes I saw here, which were 2s, 3s, and 5s. Then, I'm assuming what you did is look for the highest exponent. So on the 2, I had a 3 here, a 1 here, so the 2 to the third. I used the 3. On the 5, I only have one factor with a 5 in it, and that was to the second, and I only have one factor with the 3 in it, so this is my LCD. Now, how big is that number? Well, there are a couple ways of thinking of that just to multiply. You could just say that's 8 times 3 times 25, right? Or I can, let's see, if I have 8 and 3 and 25, what are we going to get out of that? If I have 8 25s, what do I get? If I had 8 quarters, how much would I have? $2, right? 8 quarters gives me $2, and I multiply that by 3 and I get 600. Again, you can do this in a variety of ways. What I'm looking at is, say, you have 8 here, 25 here, that's like 8 quarters, 4 quarters for 100, 8 quarters for 200, times 3. The LCD, okay, so my LCD here is going to be 600. Now what do I have to do as my next step? Change each of these fractions so they have what? The LCD in the denominator. So I want this one as something over 600. How many times do I need to get 50 to get 600? I could divide, or I could look at that and say what? 2 50s is 100. I need 6 times that, so that would be 12. So I multiplied 12 here to get this, so 12 times 7 is going to be 84. Now what we're going to do, Will, rather than sort of try to fight that through, I'm just going to slide over to the right, just about the same focus you have. We'll just walk together, going over to my right. Okay, there we go. I'm going to take my 5 over 24, and I'm arguing that I want it over 600, and I want my 7 over 50. And this is one of the harder problems you'd have on the test because there's so much involved. Now my argument is that 50 goes into the 600 12 times. So that's why I multiplied here by 12 and here by 12 and got 84. How many times will 24 go into 600? If you think in terms of quarters, $4 quarters for $1. $6 would be 24 quarters. So if I multiplied this by 25, now you could, if you want, actually divide 24 into here and you'll get 25. So I'll multiply here by 25. That gives me 125, and then what must I do to get my answer? Because remember, I'm adding here. Okay, Travis, do you want to finish it out? Okay, and what do you get? The 125 plus the 84 is correct, and that's over what? The 600. And what does that finally give us? Anybody?
209.
Do you concur with the 209? If you do, just give me a head bob. What Travis is saying is a 209. I have one head bob. 2, 3, 4. Waiting for a fifth head bob. 5. So I'm going to rewrite this as 209 over 600. Now, is that reducible? What are the only numbers I have to worry about in reducing this? The 2s, the 3s, and the 5s that gave me the 600. Otherwise, I know 2 will go into 600. I know 3 will go into there. I know 5 will go into there. Because that's how I got 600. Will 2 go into 209? Give me the argument. No, because it's not even. Will 5 go into it? Has to end in a 0 or 5. So what's the only other number I had to worry about? The 3. What's my rule for whether? Add the 2, the 0, and the 9. That's 11. 3 won't go into 11 evenly, so I'm done. This is reduced. We got it? I thought that was an interesting, a worthwhile problem. We're going to go to the document cam. We just did one with an addition. I'm going to look at a fraction here as a subtraction. So let's go to the document cam, please, Ben. It's at the bottom of the page, and I know that looks a little bit awkward. It looks like you have a couple minus signs running there. But the argument is this one is a fraction line, so that's 13 1/4, and then I'm subtracting 5 1/2. Okay, so that's the problem. 13 1/4, and you're subtracting 5 1/2. So I'll rewrite that up here on the board. 13 1/4, and I'm subtracting 5 1/2. Okay, so we can cut to the board now. Now, as you do this, what's the thing you have to be careful about when you subtract with fractions? The borrowing, right? Whether you borrow or not, so be cautious. And by the way, you need a common denominator. So if you'll set that up with your common denominator and see what trap you're in. This is one of those problems that's pretty straightforward, but it potentially is a trap, so be cautious. I'll give you a moment to get started on it. What's your common denominator? The 4, agreed? So you made this one what? 1/2 is what over 4? The 2 over 4, agreed? And that's a problem because up here I have a what? A 1 over 4, and as was stated, I have to do what? This is one choice. Cross out the 3, leave a 2. Now, where do I put that 1?
In front of the 1 over 4.
Okay, this is the important place to put that 1. If you put it right next to this 1 I'm pointing to and get 11 out of 4, you made the careless mistake. So this becomes what? 5 over 4. Now, what thing did I not do that I was critical about earlier with this problem? Go ahead. Bring that 7 down, because I'll get so excited about what I'm doing here that I'll forget the 7. So I'll bring the 7 down here. And then, last part. Subtract and get what? 3 out of 4. Agreed. And I think if you don't bring this 7 down, you court disaster potentially. You have to be very cautious here. What is an alternative to avoid the borrowing? Alternative. To avoid the borrowing. I heard a couple comments, but Okay, you threw this word at me yesterday. Unmix the fraction. An interesting phrase. I don't ever remember seeing that phrase, but I like it. Unmix the fraction. How do we do that? Another phrase for it.
Make them improper.
Improper fractions. That's how you unmix them. So I'll put here this. Okay, again, nicely done, Ben. Here I have 13 1/4. How do I make it an improper fraction? And note, you get big numbers when you play this game.
4 times 13.
4 times 13 plus the 1 gives you, I'm going to trade it in for a 53 over the 4. Now, as I say, you trade off the trap for a big numerator. Okay, what about the next one? The 5.5. 2 times the 5, add the 1, so 11 over 2. And then I have to do what? Still find a common denominator, but this is going to be times 2 times 2. So I have here 53 over 4, still leaving that as it was. And this becomes 22 over 4. So what does that give us if I take 22 from 53? 31, right? So I get the 31 over 4, but isn't that what, oh, that 4 doesn't even qualify. Okay, let me write that again. 31 over 4, but isn't that exactly what you get if you change this to an improper fraction? These two are exactly the same. Different ways of writing the same answer. So again, this is one way, and then I'm just going to rotate and come back here, and this is with improper fractions. You have a choice. They both work. So if you can avoid the trap, nice thing here is smaller numbers. Agreed? Okay, at this point, Ben, are you in 2? Yeah. Okay. With camera 1, will you give me the 21/54 divided by 3.5 that I have in the upper left-hand corner? No, with camera? Okay, where you were was fine. Leave me there. And you take the other camera and give me, if you were in 2, you were okay. And then just take the other camera and go there if you would, please. Thank you. What we do there is avoid the, and then bring it out just a little bit so I have more than half a head. Okay. We try to avoid the pan as much as we can. That was poetic, no less. Okay, here's the problem. 21 over 54 divided by 3.5. And then I'm just going to walk off camera for a moment and let you just focus on that, and then Ben can bring that in tighter if he wishes. So that is a division. What is your first step for a division like that? Okay, unmix the fraction using Travis's vocabulary. So we're going to unmix it. We're going to make an improper fraction. The 3.5 is going to be changed. That's your first step. And I would really encourage that you do that without worrying about anything else. I'm going to sort of get back through here. Lewis, if you would, please. Okay, and then I'll squeeze down underneath. You're in camera 1, right? Okay, with camera 2, can you come over here on the sideboard? Give me a moment. Just stay where you are at the moment. But camera 2 will come over here. Okay, now what I'm going to write while Ben's getting the focus going, I'm going to write 21 over 4 so he has something he can focus on. So we have a 54, and we divide it by 3.5. So I've just rewritten this problem here. Okay, now that first step, whenever you're ready, Ben. On that first step, we're going to rewrite the 3.5 as a 7 over 2. Agreed? So I have 21 over 54, and I'm dividing by 7/2. Now what am I going to do? Flip it, correct? But be cautious that you don't do 2 steps at once. Do this as your first step. Then come to here. Okay, so this becomes 2 over 7. Now be cautious here. We're going to go ahead and reduce. Cross cancel, but you can also cancel which way? Up and down. Okay, that's permissible. It wasn't, you know, typically you would hope somebody would give you a fraction here reduced, but maybe they didn't, and I didn't. So what do you see? The 7 and the 21, Lou? Okay, but do you see the 7 and 21? 7 here once, here 3 times. Now what? Okay. Jeff's saying the 2 into here and into here at 27. Now what? The 3 and the 27, correct? So the 3, and I end up with a 9. Now you have to be careful here because it looks like the only thing you have left is what? That 9, and so there's a tendency to just write the 9. That would be a mistake. What must you write instead? That is 1 over the 9. If you just left the 9, I couldn't do anything but just say, okay, you just lost the credit. We got it? Okay, Ben, to the right of where we were, we have underneath the clock with the first camera, the 5.37 and so on. You want to bring that one up for viewing? Okay, now there's the problem that's next. In the original version of that, and let me go up there, you don't need to change anything, Ben, but I'll just erase something that wasn't there originally, and all you'll see is probably an arm coming through, but that decimal wasn't there. The 36 didn't have a decimal originally. Now you put the decimal point in because you know it's there, but I want you to find me that sum. And you have a couple things you can do there to help. But first, just go ahead, and I'll leave that on the screen. You want that sum. And I apologize for the other clutter there, but this is probably working out the best. I don't have a magic eraser. Then I'd have to have a magic photo all at the same time. Okay? And that's what they meant by the magic markers. Now, while you're doing that, I'm going to write the problem as I would see it. And you don't need to look at what I'm doing if you prefer not to. Okay, and then now I'm writing it in a way I wouldn't typically write this because I think as I'm doing it, it is difficult. Okay, let's take a look at what I have here, Ben. Now, what's the downside of what I've done there? Besides, I started to increase the height of the 8 and the 3, trying to keep those in a level playing field. But what's a little bit confusing? Keeping the columns in order, agreed? So what can I do to make that better? Add the zeros. And I want to have 3 digits after each. So a 0 here, 3 zeros here, and 2 here. Now, what do you have to be careful of? The DP, right? That you bring this down. Because if you don't bring this decimal point down in your answer, I'd have to mark it wrong. Because without the DP, there's an error. Okay, the first column, the 5s, the 9s, the 7, all this gets added. So that's 14 and 5 is 19. Then carry the 1, and I have 69.795. Now, one person argued in the last hour that they preferred to put the largest number on top. So they started with the 36, then went with the 28, then the 5, and the .125. Does not matter. You have a choice any way you want to go. Now, the next problem is one that has a direction I left on the front board. We don't need to go there, Ben. It was just a direction to remind me. We're going to do a long division to the nearest hundredth again. So the number I have, I would originally write this way. For 3.2 divided by 2.34. And I want the answer to the nearest hundredth. Now this has caused us some problems in here because you have to carry it out how many places to get to the nearest hundredth? 3. You have to go to the thousands. So you have to go to the thousands to round off to the hundredths. Now what I'm going to do, Ben, we're just going to leave that up there. I'm just going to scoot out of the picture and let you go for it. So have some fun. I want that division. And I'll get the board cleaned off while you're doing that. Long division. Watch your decimal points as you carry that through. So you're going to watch the decimal point. If the eraser comes flying in on the screen, you'll just know I'm erasing. Ah, there we go. Just get this here, same way. Just give you a moment to set that up. How many digits do you have to move the DP? The decimal point? 2, agreed? Just remember that. And also remember something that now this is interesting as I come back into the screen here. If I think of this problem with a calculator, think of what you do in a calculator. In a calculator, you enter, let's see what happens here. You enter this, then you press the division symbol typically, and then you enter the 2.34. So you start here in a calculator. But how do you have to start this problem longhand? Just flip it. That the 234, and I'm not going to do the division here, but this is how you had to start it. And then just a reminder that you move this decimal 2 places to the right because you multiply by 10 to the second. You're going to have to do the same thing here. So there's your setup. Again, I'll walk off camera. That's your setup, and I want to see what you have as you carry it through. So I'm going to look at some of your work. Okay, let's see what we have. Carry it through. Come on, more. Moss. You stopped on me like grandfather's clock. Never to go again. I want to see what we're doing here. You're first. Okay, you're starting with the 1, right? That makes sense. We start with the 1. Okay, now I'm going to, again, continue looking. You're doing this division, and it's important to get it started. And we start with a, okay, we start with the 1. Now you have to be careful. What do we have for our second digit? Let me look what we've got there. Okay, you're going to be careful of what your second digit is. I see different answers. I see us starting with the 1. No objections there. Okay, so I have long division. And I'm hoping I'm not on camera yet. Okay, still looking at what you're doing. Okay. You're doing a division here. Okay, and I'm just trying to keep out of the camera's way for a moment. See if anybody, okay, I have different people getting different answers in that second digit. I've seen the right one, yes. I've seen one correct answer so far, and I may have missed some. So what I'm going to do now is rewrite the new problem I'm doing. Otherwise, I've moved the decimal point. And I'm doing this division now. Okay, we can slide over, Ben. Now let's see what we can do here as we slide over. There you go. 2, 3, 4 goes into the 4, 3, 2 one time. I didn't see any problem with that. That gives me a 2, 3, 4. And for those of you who haven't done long division in a long time, and you always do this with a calculator, this may be a little bit uncomfortable, but it's something as far as our review becomes important because we talk about this when you then go into pre-algebras and algebras and do what we call long division in an algebra class. So we really need to have you able to do this. So this is an 8 here, is it not? That changes this to a 4. I'm doing Austrian method. And a 9, and 4 is 13. So that changes this to a 3, and I get 198. It's been a while since some of you have seen Austrian method for subtraction. Then I do what? Bring down the next 0, and I need, remember, 3 zeros out here because I need to go out to thousandths to round off. And this problem has caused people a little bit of trouble. What is the next digit? I saw a lot of you go with an 8, but remember you bring down the 0 first. Then you ask how many times. So it's not 108, but 18. So you now have your 8 times 4 is 32. That carries a 3. That makes this a 7. And that makes this an 18. Is that correct? Do we agree? The 1872. So what I did over here on the side, in essence, is take that 8, and when I did the multiplication of 32, I carried the 3. That gave me the 27 and carried the 2, and that gave me the 1872. Now when I subtract, this becomes a 0 here, an 8 here, and a 1 here. Agreed? Then again, always bring down your 0 before you what? Before you ask. So I need to line that up a little bit better. That's 1080. How many times? 4? Now again, all I'm doing is taking this 2 up here into the first 2 digits. And it looks like it'll go about 4 times. It looks like I could do 5, but I'd have a carry from the 5 times 3 that would make this 11 something. So 4. 4 times the 4 gives me a 16, carry a 1, that gives me a 3, and then again carry a 1, and do I get 936? Do we concur? And by the way, I haven't done this, but thinking of what I've been doing in the algebra class recently, it's a nice reminder that we are subtracting each time. And so this becomes 4, and again using the Austrian method, that becomes a 4. This gives me an 8 and no carry, and this is a 1. So I have 144, which is a, what do we call it? 12 squared, but we have a name for it. It's 12 dozen, and what is it called, Adrian? You're giving me partial answers, but not the one I want. It's a perfect square. More than that. A gross. 12 dozen is a gross. So this is, not that it's relevant, but it's nice to know. We have a gross. Okay, bring down the next 0. How many times? 6. 2 into 14 about 6 times. 7 would involve a carry that's too much. So I get a 6 here. Okay, what is my multiplication going to give me? A 24, you should know. 24, carry a 2. That's going to give me a 20, carry a 2. And that's going to give me a 14. Do we agree? So we have 36. Bring down a 0. And I'm going to stop there because how many times will 234 go into that? Just once. Now that's my 3rd digit. That's the thousandths position. I wanted my answer to the nearest hundredth. Here's the hundredths. I'm pointing to that. So the next digit is less than 5. So what's my final answer? 18.46. So I'm just going to write here ANS for answer. And that's going to be 18.46 to the nearest hundredth. And if you could just up a little bit so I can see that and this at the same time. Okay, good. There's the solution. I'll leave that on the screen. Let's just leave it there. And then what I'll do is come back to where I'm front and center. We're going to go to a document cam in a moment, but come back to me first. Okay, so that problem is one you should be able to do in the test. Okay, and that's a little bit on the awkward side perhaps. Let's see what we can do. Okay, I'm looking for a problem I don't see here, but I'll verbalize it for you. Write this number down, 0.0025. 0.0025, and I want it as a common fraction. 0.0025. I want it as a common fraction. Okay, and we can go to the document cam now, Ben. There's the problem. So we have 0.0025 as a common fractions. What you can't read there, that's what I want. Okay, we'll just leave that up on the screen for a few moments now. And there are two approaches to this problem. Two approaches. So again, I'll write what I gave you on the board, but we won't go to the board yet. .0025. I'd like you to think how you would approach this problem. Okay. Well, no, it's not over 100. Otherwise, if I look at this, now, what Lewis is doing is talking about making it a verbal notation. You have to be careful because this is not hundredths. Let's look at our place value. Tenths, hundredths, thousandths, 10,000ths. So you would say 25 10,000ths and simply write what you said. That's one approach. Well, it'd be 25 times 10 to the minus 4.
Yeah, I meant as a fraction.
Okay. Now, up here, I could argue that I don't want the decimal point there. So what can I multiply times to get the decimal to the far right and drop it out of the problem? Well, 10 to the 4th. Move the decimal 4 places. Basic principle of fractions tells me that if I'm going to do that to the numerator, I must do it to the denominator. And this becomes what? 25 over 10,000. Now what must I do? Okay, now what you can do here, Ben, is maybe just make a cut here down to about here. Just drop the camera a little bit. That's good. So I want to do what? Reduce that. Now how can I reduce it quickly? Okay, it's 1 over something. I'll buy that. So if I divide the top by 25, I'll get 1. Now can you do this division in your head? 25 into 100 is? How many quarters in a dollar? 4. So 25 into 100 is a 4, and then you have what? How about 400? Because you have 2 zeros left. So what is your fraction? 1 over 400. So I'll just crowd that in there so I don't lose the space, and I've done the problem. Now let's slide up again, Ben, just a little bit to my original. What is that as a percent? So now we're just where you are with that, but now it's just pan with me a little bit over here to the side. Good. What is this as a percent? That's my question. So I'm going to walk off camera again and just leave that as our focal point. What is 0.0025 as a percent? And what is the rule I'm using there? Well, I want something over 100, correct? Right now it's just over 1. But what is the rule you can follow? So we come back here. When you want to change from the decimal to a percent, what do you do with the decimal point? Which direction? I'm hearing move it. You heard the R in percent, so you're going to move it to the right. If I wanted to go to a decimal, this means you start with the percent, but you ask where you're going. If you want to go to the decimal, you go to the left. Hear the L. If you want the percent, go to the right. Hear the R. So let's go back to that sideboard shot. So I'm wanting a percent. So what am I going to do?
You move it over
2 places to the right. So this is 0.25%. Write that in a different way.
25 or 0.0025 times.
Working too hard. Working too hard. Working too hard. 1/4%. Elvin's got a 1/4%. And remember where I've started with this and asked you to do what? Go up to here. So 1/4%, going the other way, meant this, but that meant 0.25 over 100, which was 10 to the second, which meant that you got 0.0025. And that's sort of going full circle. Okay, I need to rewrite something here, and then I'm going to give you the problem. This is technically much easier than some of the other things we've done. Here we go. Back to the document cam. Write it with the shortcut, change to a power of 10, and let's see what you get for your answer in this one. What do you get for your answer? Just write it out and we'll put the answer on the document cam in a moment. I'm just going to leave that there without anything else for the moment. Rewrite it with a power of 10. So how does it get rewritten? What is your power of 10? 10 to the 5, right? 10 to the 5th. So you have 275.01 over 10 to the 5th. So if you're dividing by 10 to the 5th, what do you do at the decimal? To what side? Move it over, but which way? To the left. It must be a what? Smaller number. So let's come off there for a moment, Ben. And what I'm going to do, not yet, but in just a moment, I'm going to put an answer up there. If I can bring it down a little bit tighter. Focus in. Okay, there's the number you should get. It's the center one. 0.00275001. Question. Do I need that leading 0 right here in front of the decimal point? It's optional. What areas of study typically would like to see that 0? Nursing program, health occupations, medical area, because we want to really wake up the reader that we have a what? A decimal point in the answer. Okay, coming off there. Another problem for you. Who knows what problems we will have on the test. Let's see. This is one I'm a little bit concerned about because we're still having some troubles here. This is, there we go, 75.173. And the phrase, in expanded what? Notation. So set this up. Now you can use powers of 10. That's your alternative, your option. Or you can just do it with fractions, like 1 over 10, 1 over 100, and so on. So I want an expanded notation. And again, this time, I want to walk around and look at what you're writing to get an idea how it's going. So we're dealing with expanded notation. See what you have. Now, if you've got this nailed, it'll go pretty fast. If instead you're feeling uncertain, then we may have some troubles. So I'm not sure until I see what's happening with your writing. Now remember, that's not a comma. That's not 75,000. That's 75 and 173 thousandths. The unths. I know it sounds bad, but Okay. Now, the 7 is times what? 10 to the first. The 5 is times 1, or 10 to the 0. Let's look back at the problem. The next, the 1 is times 1/10. This plus 7 times 1 over 100. And then the 3 times 1 over 1,000, correct? Let's come off there for a moment as I put a solution under the screen. Here's the left side of the solution. Now you could put 10 to the first, correct? And the 1 could be written as 10 to the 0. Coming off there for just a moment, let's look at the right side. These are the next two parts. 1 times 1 over 10 plus 7 times 1 over 100. But how could I write these two pieces?
1 times 10 to the -1.
Good. So the 1 times 10 to the -1, and then the 7 times 10 to the -2. And I'll just slide over 3 times 10 to the -3. Now, you don't have that as an obligation. Okay? You could just write it with the fractions. If you want with the negative exponents, that's rather nice. I'm watching my time here. We have maybe time for one more problem. Before I do that, just a reminder what I want tomorrow. Tomorrow is going to be the midterm. And with the midterm, I'm going to be wanting to see your books. So you should have the white book with you, the computational review. I will be looking at that during the hour you're taking your test. You should have all the exercises done from review 1 through 18. Now, I may not have checked some of your work because I'd ask you to find some time where maybe you could come to the office to do that. Not all of you have. So at this point, I need to come up with a check of that for you. You are not allowed to use a calculator. I will give you some scratch paper and the test itself. Okay? And I really encourage you to spend some time reviewing what we've done. Now that means going all the way back to lesson 1 through 18. And don't, again, just look at your work. Redo some problems in each section. Now somebody asked the question of me, with only 30 questions, that means you basically 1 or 2 problems per section, and that's about the right way of looking at it. So if I do 1 problem per section, that would be 18 problems. If I did 2 problems per section, it would be 36, and I'm only doing 30 problems. But practice. Don't just look at your work. Don't just look at the review tests you've done. I would take the review test, and I'd try to do 1 or 2 problems, redo them from each review test just to practice. And then, when you come in tomorrow, you'll have the full hour, nearly what we consider an hour. And you'll do that. Then, just for your information, over the weekend, you need to study the formula unit. Because on Monday, we have a test on formulas. And that unit over the weekend needs to be finished and have your orange book ready to turn in on Monday while you're taking the test on formulas. Okay, because we are past the halfway point at this time, coming up next week in the semester, and I need to have time to do an additional 5 units. Okay, and we need about a week per unit and some time to review at the end. So I had thought we would have time for one more problem. I'm going to give you this problem and just remind you that you may not have time. You have 1 minute to see if you can get this done. 144 over 75 and 45 over 108. You have 1 minute, maybe a minute and a half, and then we'll have to cut your losses. So 144 over 75, 45 over 108, cross cancel, cancel up and down, whatever works. We'll give you about another minute. And then I'll show the solution and we'll see if you manage to get it in the time limit. Still waiting, just so you have a chance to see it. Okay, I'm going to slip a solution under there so you can see the answer, and then you can work toward it. You know what the problem is. Let's come off there for a minute, Ben, because I am running short in time. Here, very good, 4 over 5. Let's go to the document, Cam. How many got the 4/5 already? One of you did, I know. Okay, so that was pushing you at 1 minute.